Let's go ahead and graph now y equals 3 sine of negative 2 times x minus pi over 4. So the only difference between this example and the other example that I gave you guys, or the other example that we just did, is this sine function does not have a negative, but this sine function does have a negative in front of the 2. So then what we're going to do is we're going to go ahead, and because it has a negative for the b, we're going to go ahead and use the even odd property. So what we're going to do is we're going to take this negative and put it on the outside. So again, the property that I'm using is sine of negative theta is equal to negative sine of theta. And in this case, the theta is this whole expression here. So we're going to take out the negative, so that means that y is equal to negative 3 sine of 2 times x minus pi over 4. And now we're going to go ahead and graph this like we did with the other function. So in order to graph it, we're going to go ahead and find the amplitude first. So let's go ahead and find the amplitude. So the amplitude is equal to absolute value of a, and now the amplitude is equal to negative 3. So then we're going to go ahead and find the absolute value of negative 3. Absolute value of negative 3 is equal to 3. So this is equal to 3. And we're going to go ahead and find the period also. So the period is equal to 2 pi over b. So it's 2 pi over, and the b is equal to the number in front of the parentheses here. So it's equal to 2. So 2 pi over 2. This gives me back pi. So the period is the same as what we had before. Then we're going to go ahead and find the phase shift. So the phase shift is equal to pi over 4, just like before. So this is equal to pi over 4. And that's again because it comes from this portion. Whatever the opposite of this is going to be your phase shift. This is minus pi over 4, so positive pi over 4 is going to be the phase shift. And the next thing we want to do is we want to find the cycle. So the cycle is equal to the pi over 4, which is a phase shift, all the way to pi over 4 plus the period. So pi over 4 plus pi. And it's the same as before, so it's pi over 4 to 5 pi over 4. And now what we want to find is the length between the points. And as you may have guessed, it's going to be the same. It's 1/4 times the pi, or 1/4 times the period. And because the period is pi, this is equal to pi over 4, again, just like before. So then we're going to go ahead and find the 5 key points based on the cycle and based on the length between the points. So my starting point is going to be pi over 4, and for the 5 key points, the only thing I'm writing here is I'm making a list of the x values. I'm not writing the list of the y values, because that's going to be determined by the amplitude and whether there's any changes. So we're going to go ahead and find the y values later. So the 5 key points, or the x values for the 5 key points, they start at the beginning of the cycle, so pi over 4. And then we're going to take that number and we're going to go ahead and add the length between the points, so plus pi over 4. And if we add it, we're going to get 2 pi over 4, which is equal to pi over 2. And we're going to go ahead and take pi over 2 and we're going to add pi over 4. So this is equal to 3 pi over 4. Now we're going to take 3 pi over 4, we're going to add pi over 4, and that gives you back 4 pi over 4, which is equal to pi. And the last one is going to be the last one in the cycle. So we're going to take pi, we're going to add the length between the points, so pi over 4, that's equal to 5 pi over 4. So in case you forgot where we got these pi over 4s or why we're adding this pi over 4, we're taking this from the length between each of the key points. And the number that I started out with, so it's always the beginning of the cycle, so that's the first one. And then you take the pi over 4, take the previous one and add the length, and you get pi over 2. You take that new one, you add the length, and you get 3 pi over 4. Take this one, add the length, and so on. So that's how you find the 5 key points. Now let's go ahead and start sketching our graph. So let's write out the key points. And all of these are in terms of 4, a denominator of 4. So if I kept everything with the same denominator, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, everything's in terms of 4. So I'm going to go ahead and count by pi over 4. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. Again, just like before, you can go ahead and simplify these if we wanted to. So this is pi over 2, and this is equal to pi. So the amplitude was also equal to 3. That means that the distance between the middle of the graph and the top is equal to 3. Middle and the bottom is equal to 3, meaning that we're going to go up to 3 and we're going to go down to -3. Now the first point is going to be at pi over 4. So because we had our sine function, let me go ahead and graph the sine function again. So my sine function started at 0, 0, then it went up, and then it went on the axis again. It went below the axis, then on the axis again. So we're going to follow that same pattern, but now we want to take care of this negative. This negative on the outside tells me that we have a reflection. So we're going to go ahead and reflect this. Whatever we had on the top, we're going to bring it to the bottom. Whatever we had on the bottom, we're going to bring it to the top. So, and we're going to use the amplitude. So for example, this point that's on the top, the second one, is now going to be on the bottom instead of the top. So the one in the middle doesn't change, but the one on the top does change. So we're going to go ahead and start in the middle. And instead of going up to 3, we're going to go down to -3. And then we're going to go to the middle, that one wouldn't change. And instead of going down, now we're going to go up to the 3. And then the one in the middle, again, does not change. So then it goes below, and then it goes to the axis, and then it goes above the axis, and then again touching the axis. So another way that you can find these y values is you can look at the points that we had. So originally, we had 0, 0, we had pi over 2, 1, and then for this one we had pi 0, and this one was 3 pi over 2, -1, and for this one we had 2 pi 0. We could also take the y values, and just like when we were doing transformations before, when we had a negative in front of the 3, so if we had a negative on the outside, then what we would do is we would multiply all of the y's by a negative. So that's what I would end up doing here. And because the amplitude is equal to 3, instead of just multiplying it by a negative, we're going to multiply it by -3. So then this 0 times -3 is equal to 0. That one stays on 0. And then I'm trying to figure out what the y values would be. So I'm not going to worry about these right here. So I'm going to use only the y values for this. So we're going to take the y value, the original y value, 1, multiply by -3, you get -3. So this second key point, which is now at 2 pi over 4, is going to have a y value of -3. For the third key point, so this third key point has a y value of 0. So again, we're only looking at the y values. And you multiply the y value, the original y value, times the -3. So 0 times -3 gives me a 0. Then you do the same thing for the next one. -1 times -3, that gives me a +3. So now it's above. And for the last key point, 0 times -3 is equal to 0, so it stays on the axis. Now what I want to do is I want to give you an example of just finding the period and just finding the phase shift without any graphing. And that's when the function is not already in the form that we want it in. So if it's not already in this form, we're going to put it into this form. So let's go ahead and do that for the next example. So on the next one, just find the period and the phase shift. For y equals 2 sine of 3x plus pi over 2. So what we're going to do is, because we don't want a number in front of the x, we're going to go ahead and factor it out, but we're going to factor it out of both of these. So if we factor it out, it's the same thing as dividing it out. So this becomes y equals 2 times sine, And again, I'm going to factor out a 3. And when I factor out a 3, it's the same thing as dividing out by 3. 3x divided by 3 gives me just the x. And then I took out a positive, so pi over 2 divided by 3 is going to give me pi over 6. So just as a side note, pi over 2 divided by 3 is the same thing as pi over 2 times 1/3. So times the reciprocal of this, which is equal to the pi over 6. So that's where I got this pi over 6 from. So now that I have the function in the form that I want it in, I can go ahead and find the amplitude, which is equal to absolute value of a. A is equal to 2 in this case, so absolute value of 2 is equal to 2. And then for the phase shift is just the number that's after the variable, after the x, and you take the opposite of that. So the opposite of positive pi over 6 is going to be negative pi over 6. So this is telling me that this function goes back by pi over 6. This phase shift of pi over 4, again, it's the opposite of this, tells me it's going to the right by pi over 4. Alright, so the amplitude again is equal to 2, and the phase shift is equal to negative pi over 6. So if I wanted to graph it, I would go ahead and find the cycle. I would also find the length between the points, and then I would find the 5 key points, x values, and based on those and based on the sine functions pattern, I would go ahead and graph it. So I do want to show you guys a cosine function though, so I'm going to leave this one to you guys to go ahead and try out. And I do want to do the cosine function. So let's go ahead and find the graph. Of y equals 1/2 cosine of 2x plus pi over 4. And let's go ahead and add a 2. So we have a shift on the y's also, meaning my cosine function, instead of being at the center of the x-axis, instead of being centered here, we're going to take this cosine function and we're going to push it up. So because we're adding 2, we're going to push it up by 2. So my center, if I think of this as a y value, it's y equals 0. So my center now is going to be 2 above that, so it's going to be at y equals 2. So let's go ahead and graph it. Before I can actually graph it, let's put it into the form that we want it in. So we want to make sure that we have a, we want to make sure we don't have a number in front of the x. So we want to have b separate from the x. So let's go ahead and do that. Just like we did on the previous example, we're going to go ahead and take out that 2. In other words, we're going to go ahead and divide it out. So cosine of, and we're going to take 2 times x plus, and then pi over 4 divided by 2 gives me back pi over 8. And this is plus a 2. So we're going to go ahead, so y equals 1/2 of cosine of 2 times x plus a pi over 8 and then plus 2. Let's go ahead and find the amplitude now. So the amplitude is equal to absolute value of 1/2. So it's the absolute value of the number that we have in the front. Alright, so again, amplitude is equal to absolute value of 1/2. This is equal to 1/2. So we're going to go ahead and find the period also. The period is equal to 2 pi over b. B is the number in front of these parentheses, so it's 2 pi over 2. So this gives me back a pi. Then we're going to go ahead and find the phase shift. So the phase shift is equal to the number, or the opposite of the number that's next to the x on the right side. So opposite of positive pi over 8 is equal to negative pi over 8. So this tells me that the cycle starts at negative pi over 8, and then it's going to end at the phase shift, negative pi over 8, plus the period of pi. So we always take the phase shift, and that's what goes first, and then it's going to be the phase shift plus the period. So that's how we determine the cycle. So this is negative pi over 8, and the ending point is at pi over 8. So if we add these two, we're going to get back pi over 8. So negative pi over 8 plus 8 pi over 8 is equal to, it's actually 7 pi over 8, sorry, not pi over 8. So 7 pi over 8, and the distance between the points is equal to 1/4 times the period, and the period is equal to pi, so this is equal to pi over 4. So we're going to go ahead and start our cycle at negative pi over 8, but then my distance between the points is pi over 4, so it's a different denominator. Let's go ahead and change this so that it's going to be easy to go ahead and add to these numbers. So I'm going to change it so that I have a common denominator. So I'm going to change it to 2 pi over 8. That means I'm going to be adding 2 pi over 8 each time. So I'm going to start at the negative pi over 8. So negative pi over 8 is the first one. Then we're going to take that number, negative pi over 8, and we're going to add the 2 pi over 8. So this gives me back a pi over 8. So if I do the same thing for this one, I'm going to take pi over 8, and I'm going to go ahead and add 2 pi over 8. So this gives me a 3 pi over 8. Now for the next one, we're going to take 3 pi over 8, and we're going to add 2 pi over 8 again. And I'm adding 2 pi over 8 because that's the distance between each of the points. So it's a distance between each of the x values technically. So this is 3 pi over 8 plus 2 pi over 8 gives you back 5 pi over 8. So we're going to stop at 7 pi over 8. So that means 5 pi over 8 plus 2 pi over 8 is equal to 7 pi over 8. If your numbers do not match, so after the fifth one, if it does not match this last one, then you've done something wrong either here or you've been adding something wrong. So double check your addition and then double check this last number as well. So the first one should match the first number in the cycle, the last one should match the last one in the cycle also, after you have your 5 key points. So let's go ahead and draw out our cosine function for this one. So we're going to go ahead and I'm going to go by pi over 8. So I'm going to start at negative pi over 8. So this is going to be negative pi over 8. Then this is pi over 8, and I'm going to go by pi over 8. I'm not going to jump to 3 pi over 8 after the pi over 8. So the distance between each of these values has to be equal also. The distance between here and here is equal to pi over 8. Distance between here and here is pi over 8. So I'm going by pi over 8 each time. So this is 2 pi over 8, and then this is 3 pi over 8. This is 4 pi over 8. This is 5 pi over 8. 6 pi over 8, and 7 pi over 8, and I'm just going to stop at that 7 pi over 8. So you might notice that I have more numbers on here labeled than what I have for the 5 key points. We're just going to go to the 5 key points and we're going to find them on our labels here. So the next thing I want to do is I want to use that amplitude. Before I can even use the amplitude though, we want to make sure that we have, or we want to check to see if we have any shifting. So we have a shifting or a shift going up by 2, so let's go ahead and make that shift going up by 2. So this is 1, this is 2. That means that my function is going to be centered at the 2. So before, my cosine function was centered at 0, so let me go ahead and show you. The cosine function was centered at 0, and I went above, below, and above that center. And now what we're going to do is we're going to center this at the 2. What I would suggest is for the center, if there is some kind of shift, draw a dotted line or draw something to show you where it's going to oscillate around. So this is not part of the graph, but this is just going to help me draw my points. Let me also go ahead and go up by 1 more, because we're going to need to go above that center and below the center as well. So let me draw also the cosine function. So the cosine function is above, and then it went below, and then it went above. So these are my 5 key points: above, on the center, below the center, on the center, and above the center. So because there's no reflections on this function, then it's going to keep that same shape. So we're going to go ahead and go above the center, So how much are we going above? It depends on the amplitude. In this case, the amplitude is 1/2. That means I'm going 1/2 of the weight above the 2 and 1/2 of the weight below the 2. So that means we're at 2.5. So again, we're going to go above, and my first key point is at -pi/8. So go to -pi/8 and go above by 1/2, and that's where you would draw your point. Now your second key point is at pi/8, not at 0, but at pi/8. So this second key point was on the center, so we're going to go ahead and go to the center and draw a dot on the center at pi/8. And then 3pi/8 is the next one, so again, don't go to the 2pi/8, but to the 3pi/8. Third point here corresponds to the third point here because there's no reflection, it's below the center, so this one's going to be below the center. Take care of the amplitude, meaning we're going half below the center. Center is at 2, so then we go half below it and we get 1.5. So then the next key point is at 5pi/8, so we skip over the 4pi/8. This was just to go ahead and draw the x-axis to scale. So the 5pi/8 is my fourth key point, so this is first, second, third, fourth. Fourth is on the center. 5pi/8, you go to the center. Next one is 7pi/8. So the fifth key point is above the center, so we're going to go ahead and draw the 7pi/8 above the center, and we're going half above the center, so 2.5. So this function was shifted to the left, and it was, think of it as being squished or compressed. So it was shifted to the left, it was shifted up also, and then it was compressed. So we're going to go ahead and graph or connect our points as best as we can.